How's it going, everybody? I think at this point you probably have already heard of the Linux kernel drama. There was a shitstorm about I forget what's the file system called, but there's a shitstorm going on in the file system. I'm to be honest, I can see where they're coming from. But at the same time, I don't know. I was actually planning to do something more productive today, but I can't. I'm lazy, so I'm here doing the reacting to a video on the file system in Linux, Cans Overstreet.
But I'm the one who is actually sending the patches for the file system abstractions. So we decided I'd show you guys a few slides and then we jump into discussions. Kent also has a list of things in addition to what I'm going to show here. I'm going to try to be brief so we can spend most of the time on the discussions. Okay. So a quick status on where things are. For those who may not be following this, I sent an RFC patch series sometime last year, and there's some links here. And, there were some suggestions for things to change, and I made those changes back in January, and I just posted them on Zulip. I didn't actually send them to the mailing list, but I did it this morning. I was planning to send them earlier, but I decided to wait until the morning after a few beers last night. So a little bit of the goals of the abstractions, why we're doing this work of building these abstractions in Rust. Basically, in Rust, we have the ability to express.
Let's see. The bullet points are express more requirements in the type system. More mistakes caught at compile time, which is kind of interesting, right? Well, I think I'm not sure what it means, but I think it's possible that this is a very true point, right? Rust is like one of the reasons why I'm using Rust is the compiler and the language tooling is actually sensible.
More of the intent of the code or the
automate some tasks. That one is questionable. I'm not exactly sure what it means by automate. Right? Fewer opportunities to introduce bugs. What does that mean? Do they mean the test or what? A more productive file system development experience. The sub points are less good in my opinion.
The requirements that the code have in the type system, and this allows us to catch more bugs at compile time, and I'll show you quickly a couple of quick examples afterwards. It also allows us to automate some tasks that are not very easily automatable in C, and I'll show you a small example later too. And the result of these two things is that we have a more productive developer experience when we are writing file systems in Rust or code in general. When I had something, Ken? No. Yeah, so as I said before, we get more bugs caught at compile time. We spend less time debugging these issues. So when I talk about developer experience, I'm not just talking about the time you sit down and you spend writing the code. I'm actually talking about the time afterwards when you try to deploy the code and there are issues and you have to investigate those perhaps in production. So you save a lot of time by catching those bugs earlier. And of course, we also have fewer memory-related vulnerabilities because of the undefined behavior guarantees that Rust offers, and those sort of eliminate modulo some bugs in the compiler and abstractions. It eliminates memory safety issues.
In my career, I've seen a lot of
I need to grab some drinks. Just wait for me.
massive 2 weeks, all hands on deck bug hunts, and we all have. Those kinds of bug hunts suck, and I've been doing a lot of work in Bcachefs to try to
Sparkling water for your local business.
eliminate those and come up with better assertions and so on. Rust
27%
does a lot more than
fruit
anything
juice.
I could do. The two main threads that I've been pushing on, and then I'm going to be talking more about the Bcachefs BOM, are
it tastes like ass. What the fuck?
undefined behavior, eliminating undefined behavior, and also better reflection. You can't debug if you
Well,
can't
maybe
see
it doesn't
what's
taste like
what,
ass. It's just like kind of
you can't
unexpected.
debug if you can't see what's going on. Rust has some really nice provisions with that are kind of
It tastes
secondary,
like-
but very useful.
It's a lot more
And
than I anticipated.
lifting us. We don't talk about enough assertions in
Which is
the
actually
kernel
kinda nice,
because
but,
reasons.
Just my
But-
expectation.
The end goal, like what I see in a couple decades out, kernel development is going to be getting a whole lot easier over the coming decades. The end.
I feel like this is where the shitstorm starts, right? You're making an assertion saying kernel development is going to get like a whole lot easier in the coming decades or something. Like, on one hand, I can see where he's coming from, but on the other hand, is it really easier though? Cause like the thing is, like, the Linux kernel community has been very cautionary when it comes to adopting new things, right? Like, and I was even like shocked when I learned that the Rust got into the Linux kernel, which is really weird. I still don't understand how that happened. But like when the other major operating systems like Mac OS and Windows has shifted to C++, Linux didn't do the same thing, right? Because because I am always kind of against the idea of like introducing new languages to existing projects, even when there are certain benefits, right? My argument for that is it's going to make the tooling a lot less portable. Like, for example, now Linux runs on pretty much everything, and if you want to port Linux to a new system, all you have to do is to have a C compiler working, which is fairly easy, you know, if you have a new CPU, brand new architecture, and you only need to make sure C compiler is working. It's fairly easy. You can port GNU, the GCC, right? GNU GCC. GNU C compiler. Like, but like the thing is, Rust is different, right? Rust is built upon a very bloated compiler and a very bloated. The tooling of Rust just feels very bloated and not portable. I'm not exactly sure if that's something that people necessarily want to have, right? And also, you gotta understand, whenever you introduce a new thing, and say, oh, by introducing this new thing, will make the development experience a lot easier. You're making an assumption that in the upcoming decades, Linux kernel will be largely, if not fully, developed in Rust, right? Because if that's not the case, what will end up happening is that any new developer who wants to do meaningful changes to the kernel has to learn both C, not learn, but has to be fluent in both C and Rust. It's just like the React thing, right? You have like higher order function, you have like all those extra crap. Like, yes, you can have all of those new features, but you gotta understand the old legacy codes are not going anywhere anytime soon. And by introducing a new language, a new design paradigm, you create a lot of frictions to new developer. I do not think Rust is an easy language, like purely from an easy to use perspective. I think C is a lot easier to write. Yes, you're gonna shoot yourself on the foot, but it's easier to write. Your shell at least compiles, whereas Rust kind of prevents you to do a lot of things which are sometimes necessary, right? And that is why you see so many Rust code just ended up with like unsafe block all over the fucking place, because like that's not what Rust is designed for, especially, and the unsafe debugging experience in Rust is also pretty bad. So anyway, let's continue.
End goal that I want to see is a programming experience where we've got a language where we can practically do embedded correctness proofs, where we know when we write the code that the code is correct, so that when I finish a project and move on to the next thing, I know that I'm not going to get yanked back to that previous project debugging things. That's not fun. It's not productive getting yanked off to, the code that should have been done months ago. Assertions are what we're stuck with in C, but Rust can actually prove not just the simple stuff that you think with references, but you can prove a lot of code correctness issues just with what Rust gives you, and we'll be talking more about that.
Thanks, Kent. A simple example here of the expressiveness of the type system. Okay, so this is I get locked. It's a simple example. Okay, but it's just to illustrate how much easier Rust makes using this function, right? So as most of you probably already know, when you call this function, you have to check, of course, if the function failed and return null. In that case, you return failure.
I think one thing that's very nice about Rust is that its type does kind of tells you what you should do with the types. Like, for example, the super block SB here does not necessarily tell you what kind of checks you will have to do to get this working, right? Like, it's totally possible for me to like just go grab something and not ended up doing it. But I can't say I'm a big fan of the Rust semantic, because like by forcing you to write, some num, like that's verbose. That's very verbose, and I can definitely see if you know what the API tells you to do, it's kind of redundant. But I feel like it's also a good tool to prevent like human errors, right? So I'm thinking about like if there's a way to kind of forces you to check certain things before you can proceed. I think that might be a better way. Like I think that's one thing that both Zig and TypeScript has done great, right? It's the idea of like, okay, we are not going to have, Monad everywhere and basically forcing our ideology and stuff. We're trying to add some like syntax sugar to existing patterns that's incredibly common among the old APIs, right? So I'm kind of wondering if there's any way to kind of extend this to beyond null pointer, because I think null pointer is such a stupid topic. Like I still don't know who thought to themselves that, well, you know what we need? Null pointer. That's nonsense. That's a bunch of baloney.
Perhaps. But if it's non-null, then there are a few things you have to do. You have to look at a field, the iState field, to see if it's a new inode or if it's some existing one, right? Because here you're trying to get it if it exists or create one if it doesn't exist, right? And then if it is new, then you have to initialize it and you have to remember to call unlock new inode.
Yeah. The key word that makes all this possible is algebraic data types. C++ is just now trying to get algebraic data types, and they won't be ergonomic ever because it's C++. Rust has really amazing algebraic data types and error handling.
Yeah. But then, yep. Go ahead, Al.
A bit of correction. It is ref counted from the very beginning.
I'm sorry, say that
It
again?
is ref counted from the very beginning.
Sorry, I could.
inode is if I get locked returns non-null,
Yeah.
the result is ref counted.
Is ref counted? Yes, yes. Did I say
It's,
it isn't?
I get failed expect the holder of the sole reference to pass it to it, and it drops that reference. It's
You don't expect the owner to do what?
what you have in case of inode being actually new is slightly misguiding. It is ref counted.
No, yeah, I'm claiming that
Definitely
it is.
so.
Yes.
It's not that you can call unlock new inode and blah 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 inode is ref counted. Otherwise, call I get failed if init fails.
Oh, yes, yes, okay. I see what you're saying. Yes.
I get failed takes the reference. It must be. It assumes that it will be the only reference
Yes.
existing to the object, and it drops it.
Yes, yes. I didn't try to claim otherwise. Yes. But what I try to claim though is that you have to remember to call I get failed, right? If you just drop the reference, for example, that's not sufficient. You actually have to call I get failed. That's what I was trying to say with that line.
Quite have to. You can do equivalence of it.
This is where the shitstorm starts. This is gonna be painful to watch. And I do think like a lot of people are saying, oh, but the C people don't follow development and stuff. I mean, in some ways I can see where they're coming from. Like, just based off, like, I'm not making a generalization here because I think that's not a healthy way to approach that. But that guy who just like went on the stage and pointing out like, well, actually, is definitely not making an attempt into understanding the argument for Rust, right? And I feel like this is like a really difficult problem for most projects. Like most projects, a lot of people just say, oh, just do the work, just code or whatever. But you will very soon realize that's not the case at all. Like, we're living in a society. It's very unfortunate that we're living in a society, but the consequence of that is we kind of have to obey the same rules, right? We have to kind of care about other people's feeling. And the failure to recognize that is not going to make you a good presenter or speaker or maintainer or programmer, right?
Sure, right. You have to get the facts of I get failed. You don't have to call it, but you have to get the facts of it.
I think the broader point here is that this is the kind of discussion that we won't have to have anymore because the
Yes.
compiler will know.
Yeah.
Well, I think the
Yeah.
point is you don't need to have this discussion now. All you're saying is there are two possible return paths from I get, and we're going to use Rust to unify them, right? That's the
Yes,
statement.
that's what I'm trying to say. Yes, yes. We don't want
Yes.
to.
I think they're like, I don't think so. Like, I think the way that they are. Let me think about how to phrase this. I think the presenter is also kind of not doing their best in presenting their views. What I'm trying to get across is like, they kind of assume people have great knowledge about Rust, which most people don't. Like, I can assume most people sitting in the conference are, C developers. They don't necessarily know Rust. They know, like, maybe know Rust is a safe language, things like that. But to be honest, it kind of came across to me as sort of condescending. Like saying, oh, this is the old way, this is bad, and we have this brilliant new way of doing things. I mean, it does feel like that to me, even though I'm pretty sure that's not their intention. I'm pretty sure that's not their intention. Because, like, if you're trying to get your point across, do not use terminologies that is specific to languages, right? Like, what is that? Algebraic data type and all that kind of crap. Like, people don't know what that is. People just don't know. Like, or maybe some people know, but like most people don't know what that is, right? And when you're using terminology like that, it feels condescending. It feels like you're trying to claim some kinds of intellectual superiority, in my opinion. Because, like, a healthier way of talking about this is definitely, illustrating the problem, talking about how to solve it, and introduce the concept, right? I think that's a healthier way to approach this. But again, like, I think part of the reason why so many programs just become like an absolute shit show is because, like, most programmers are introverted people, and when you have a bunch of introverted people, the communication just becomes increasingly harder and harder. Like, I also saw the comments from the Asahilina, right? She's very condescending when it comes to things like implementation, because, like, she just straight out say, oh, this is a poorly designed API. I mean, maybe it is, who's there to say? But, like, when you are, I think Rust is the swear word in the Linux community, because, like, that's not something that most people are 100% on board with. And when you're kind of like constantly telling people about the superiority of Rust, it does feel like people are trying to use Rust to replace C. And that is definitely uncomfortable for many C developers, right? Like, you are trying to not only writing new things, you're trying to replacing the old things, and that is like threatening to like many people, because, like, it's very unclear that if, let's say, we just change this to the Rust API, how would the C API proceed? Like, are they gonna continue develop the C API? Are they gonna become like a Whopper to the Rust API as opposed to as opposed to the current way, which is the other way around, like the Rust API is a wrapper to the C API. Are we going to move to a point where the C API is actually a wrapper to a Rust API? That just introduced like a lot of mental overhead, if that makes sense.
To get into this, but yes, but it's exactly the point. So what I'm trying to show here is that there's a set of steps and set of functions that you have to know that you have to call under certain conditions, right? And what the result is.
I also want to give a shout out to Christian Bronner and Alice Ryle. The early Rust festival discussions were kind of contentious and frustrating to me. The work that they've been doing recently is, I want to just give a hand to them. Christian has been explaining aspects of like FD references that I wasn't even aware of, and now we're encoding that into the type system. This is going to make all our lives so much easier.
So next slide shows you the equivalent in Rust, okay? And the thing that I'd like to highlight here is the result type. That's what matters to us. It makes.
Imagine you're a C developer. Imagine you're a C developer and you saw this. This is just yapping, right? This is just yapping at this point. Like, what does that mean? What does that mean? Like the C API is, the C code is simple. It's very simple, right? Even though it's not, I'm not sure if it's actually easier to use, but it is simple, right? Whereas in Rust, you kind of get this abomination of like, this is an abomination. Okay, another thing that I'm not entirely sure about Rust is the types. So like, the type system in Rust is powerful, but it does seem to me that the refactoring process for the Rust API has been incredibly hard. Like, if we've got like a C API like this, right? If we add a new field to Superblock, I would assume it's probably not going to result in like a lot of changes, right? It's probably not going to result in a lot of changes. You can use pretty much all the old code. But let's say, for example, if we want to change something here, I guess my problem with Rust is like the types are kind of inconsistent. So like aref,
right, so we have to check.
IDA result. Aref, I'm not sure what aref is. I think IDA results are pretty clear. But aref, it does feel to me like something that should be in the inode, right? It does feel to me like it should be something that's in the object, because you will have like the reference counter, right? It does feel like something that should belong to the object, as opposed to some kinds of like wrapper type, if that makes sense. So I'm kind of wondering, let's say, for example, hypothetically, we are replacing the aref with some other kinds of like reference counting. What would that be like? Right, you will kind of have to change everything everywhere else, which is really slow. I don't know. I think refactoring Rust is hard, just based on my limited experience.
Allow you to use the inode on failure because there isn't an inode. But on success, you have two options, right? You either get a ref counted inode that you can just use and that's fully initialized, or you get a new inode I mean, it's not initialized yet.
I do feel like this is a hard presentation to do. I just realized this is a really hard presentation to do. Like if the people sitting there don't know Rust already, this feels like an inferior approach, because like you have a way more complicated function signature, and you also have like a lot of cognitive overload, and you also have like a lot of magic going on. So like I'm not sure if ref count automatically decrease is a good thing or a bad thing, because I don't know, I sometimes I appreciate the expressiveness of C, because I don't like macro for kind of the same reason, but I do appreciate the simplicity of C, which kind of allows you to have a very holistic view towards what is going on the system. And I think a while back, Linus also gave a speech on why he hates C++, specifically citing you don't really know what's going on under the hood. That's like too much abstractions. I feel like I kind of get the same feeling with Rust. Like they're trying to do these smart things, but sometimes I'm not sure if the smart things are actually smart or it's actually just stupid, right? Oh yeah, one example of why this might not be a good idea. What if we want to switch like something here? Because like a lot of times you warp something with something, but what if, let's say, you want to switch the either with results, right? Like it will become kind of hard to know if that is something that you want to do, right? It becomes kind of hard. I guess that might not be the best example, because in this case I don't really think you can swap them, but you can definitely imagine in some cases you can, like for some APIs you will want to swap the order of them, right? And sometimes, because the reality is the only type that we care right now is the inode type and the new type, right? Those are the only two things that we can possibly care about. And you just swap it around with like all this other crap, which are, you know, helpful, but also they're crap.
And then if for some reason while you're initializing you fail, then it goes out of scope, it gets dropped, and then automatically the right function gets called, right? That's the idea. You don't actually have to know that which functions you have to call on success, on failure. It just happens. And if you forget to do any of those and you're required to do it, you'll either get a compilation error or your code will return an error, something like that. But the idea here is that a lot of the things that you sort of have to know about the semantics of these functions and things you had to do but were sort of implicit.
I do agree with the idea that, you know, having to know the semantic of the superblock and all the other things can be hard. I think, and this is what I'm so conflicted about, because like I think a lot of times it is just a hard data type, right? It's a complicated data type, and we're trying to express that data type in different type systems. Essentially, that's what we're trying to do. With C, you get more of a, you know, manual approach to the data type. You can even like raw dog memory addresses. But like for Rust, it's different, right? It doesn't encourage you to raw dog everything. Kind of has a lot of whoppers, but I do think that introduces a lot of complexity that's sometimes unnecessary.
You wouldn't have to know these things in advance. You sort of be guided through the type system with errors at compile time on how to do these things.
I think one reason this just becomes such a shit show is because if you're not familiar with Rust, that is just yipping, right? It kind of feels like, oh, trust me, bro. Just take what I've said. So it does. I can definitely see why it can come across as religious in some way.
I'm gonna say something.
Let the shit storm begin.
So basically you are splitting ref type pointer to inode in two.
I'm rejoining. Say that again. Sorry.
Basically, you are splitting a pointer to inode in two types. One is normal ref counted.
Yes.
Another is kind of sort of, and it's actually not just a chunk of memory.
So,
Destructor for that new.
Yeah, I think this is one thing that I encounter a lot when talking to C/C++ people. They really care about the representation in memory. And I do think for kernel level work, that is important. And Rust strongly discourages you to think about memory. I think I don't like to think about memory. I just never liked it. But I can definitely see if you're someone who has a background in system engineering and wants to know the nitty-gritty hardware details of your software, you will kind of have to care about memory. But Rust does hide those complexity away, or they're being exposed in a very indirect way, so to speak.
Inode
yes.
is a lot more.
Yes. That's the
Parts of that are already initialized, and you can't just forget about it. You can't just remember.
Exactly. That's the thing. The destructor of new inode is going to call that iGetFailed thing to destroy the thing. So it's going to call the right function. So I'm trying to say is that you don't have to remember or know which function you have to call. And then there's one thing that I'm not sure if I mentioned here, but when you initialize that inode, the new inode, it turns into the regular inode. So it's just a wrapper type, right? That has the semantics that it's a new thing.
Right, this is how is this not confusing to someone who's new to Rust? So I feel like it feels like a circle jerk to me, if that makes sense. You have to know Rust to know this is the power of the type. Otherwise, it looks extremely confusing. What the fuck is all of this? And they also didn't show us the definition of those types, right? Just with this single slide, how do you know the inode : new is just inode? I mean, I can infer it. That's kind of sort of what I've done. But for people who want certain level of precision, it feels really weird.
And you have to call init on it, right? If you don't call init on it, then on drop it gets iGetFailed. If you call init on it, and then it's initialized, and it's a full-on aref inode, and you can only call init once. If you try to call init twice, and this comes from the type system as well, it fails, right? So you have a new inode, and you can only initialize it once. That's another thing.
So basically, you are C equivalent would be to drive annotations through uses of those pointers and have the function that currently calls iGetLocked to express that as switch from.
You could do something similar in C, but the thing that I was going to say is that you cannot do equivalent thing in C. The things you'll miss in C is the, for example, the ability
Oh no. He just said you cannot do the equivalent thing in C. It's trying to say C is an inferior language. I mean, C is pretty old. Let's just say that. But all languages are Turing complete, so they're kind of the same, and you can kind of do the same thing.
to only call init once, right? You cannot do that in C. This actually comes from the type system being substructural, right?
Not
C doesn't have that.
Yes, I. No, well, how would you express it in Haskell, whatever? Okay, so basically, you are saying that, okay, how much of those annotations need to go into the source? How much of that is automatically derived, and how much is?
There's nothing of this is derived. We actually have to get experts like yourself to tell somebody who knows how to write those rules down, right? And
here's where, like, you can see that that guy is getting extremely confused, right? He's just not getting it. He's actually just not getting it. He's like, I'm losing it. You can definitely see, like, why this is such a mental burden to someone who's not already familiar with Rust. Like, the current API is not ideal, but it works, right? It works. It's just, like, not ideal.
but so the idea here is to
And like, if you can't even show like the like implementation, this guy.
extract information from you and others in the room, right? And encode them in the type system, right? And then when people are actually going to try to
Yes,
use
but
that,
where in the resulting source will that information be encoded?
oh, it's in the source code. It's in the implementation of that, right? A version of which I sent to the mailing list today. If you could spend a few minutes looking at it, I would appreciate it.
Either there corresponds to the IU check.
Yes, that's one part of that. Another is how do we, well, actually unlock new inode is actually needed. It's, there are non-trivial cases when you want that sucker to be locked after successful.
You can see that person just don't get Rust, right? Because like with C people, you're used to the idea of like calling a bunch of functions and no hidden control flows. Well, there are some hidden control flows, I imagine. I'm not that familiar with C, but like very minimal hidden control flows, right? There's no like magical enter fucking scope and lifetime fucking reference count and shit like that. Like, this is very foreign to C people. Like, you can definitely see that person is just a C person, right? He's saying, oh, but how, if you're not calling the function, how to do it? Because we're supposed to do that, you know, there are non-trivial cases where that happens. Whereas Rust people goes like, well, we have everything in the type. That's just how it works, right? We have all the like automatic data flows, automatic control flows, which is pretty nice, right? Which is pretty nice if you're trying to like move fast and stuff. But it's confusing. It's definitely a different paradigm, and I'm not sure if one is strictly better than the other.
Well,
So
not
in the
quite I
case-
get locked, but I get locked 5, I think, where you are using not a number as a key, but as additional
Yes.
data structure.
Hopefully we can find ways to boil that stuff down.
I wasn't leaving. But no, I wasn't going to.
So you essentially need to say, at some point say that, okay, I'm done with that lookup, and we could try to push that into callbacks for I get locked 5. If you actually look at it, it's more generic variant of this,
Okay.
where we're using not a number, but something else.
Oh, for the uniqueness of,
As a key?
of the, yeah.
No,
Yeah.
it's not exactly uniqueness. It's when we are looking by something different.
By something else. Yes, sure. Yes.
Then we are passing predicate and another callback for setting. We could kind of sort of push everything into, make sure that unlocking isn't needed in the caller.
Yeah.
Go ahead, Dave.
Yeah.
Yeah, and I'd be happy to generalize.
I think he's kind of confused. Like I think he's kind of confused by like what the presenter is trying to speak. Like it feels like he thought that the presenter is trying to say, oh, with Rust you kind of don't have to do a lot of things. That's not what Rust is all about. It's about like enforcing those steps. I think that's possibly a better way to say it, because like Rust kind of Rust just enforces you to do a lot of things, and you'll still have to write it yourself, right? A lot of times, and that's what kind of make Rust frustrating to write, because you do have a lot of things that you kind of have to write, and it's kind of for roles. But in return, you get great safety and hopefully a more correct software.
This, I like the idea. Sorry, go ahead, Dave.
So my question was going to be, just looking at this, we're talking about the C code, which is I get locked. The Rust code that you've written, that function name is get or create inode.
Yeah.
There's a complete disconnect there between the C API and the Rust API. You can't...
Yeah, that's true. That's true, right? Those two are two different APIs.
We can't look at the C code and know what the equivalent in the Rust code is.
That's a good point, right? But I think this person is trying to, the Rust guy is trying to do it in a idiomatically Rust way, and the C guy is like, yeah, but how does that interrupt with the existing C API, right? I think both have a point. Like if you're not doing Rust in a idiomatically Rust way, you're not going to take advantage of a lot of like type safeties in Rust. And if you're doing it in a idiomatically Rust way, a lot of functions will behave differently, and like a lot of things are defined differently.
They need to have essentially the same names.
Sure.
And that's across the entire API. Having a completely different, unfamiliar API for the Rust code does not help us review it and
That is true. That is definitely true.
determine what it is. And I mean, realistically, this is what James was going to ask, is that this is kind of encoding the object model into the function prototype. What happens when we change the object model in the C code?
So we're going to have to change it here too, right? So this is actually a problem.
Okay, yes, it will have to be changed. Who's going to do that?
Yeah, that's what I was trying to say. Like, introducing new languages, especially with a language that's just not compatible like Rust, into something like C, into a large C project, you're going to have, and especially when two sides of it are like under active development, what you're going to inevitably end up with is two sets of APIs that are kind of inconsistent, and that's kind of hard to maintain. Like, the existing API is already kind of hard to maintain. Who's going to maintain that? Like, it's not like a company, right? And that is why I think Rust is more of a corporate language than a open source language, in the way that Rust does allow summer intern to not fuck up the system, for lack of a better term, right? But it does require a huge commitment of doing everything in Rust. It's kind of like the it's kind of like what the U.S. government is trying to do, right? They're trying to report everything into Rust. So like for most companies, when they say we're adopting Rust, it's more like we're kind of gonna halt on the existing C APIs or making minimal changes to the C APIs, and we're trying to move big chunks of our systems into Rust, and we're going to do all the future development in a idiomatically Rust way. But that's different from the open source project, right? Open source is like there's a much larger inertia. I would even argue it has a larger inertia than the corporate, because with corporate you at least get like a head of a company or like a tech lead just pointing out the direction of the company that they're going, and everyone just kind of have to follow them, right? With this totalitarian system, you can push like very aggressive changes like adopting a new language and halting on existing things. But with open source, it's impossible. It's just not happening. A lot of people are saying, oh, maybe in the future there will be a big chunk of Linux that's being written in Rust. I just don't see that coming. I feel like either you get a kernel that is fully Rust, or you get a kernel that is fully C. Otherwise, what you're gonna get is a Frankenstein bullshit crap. Right? You're just gonna get crap. I don't know. Maybe I'm just too stupid to understand.
Yeah, so this is part of...
It'll have to be done at the same time, because we can't change the C code and have Rust code that behaves differently.
Yeah, that makes a lot of sense.
And so there's a disconnect there that we need to, resolve.
Yes, this is part of what we need to discuss. Yes, that's right. I agree with that. Yeah.
Actually, I'm kind of surprised that XFS folks hadn't given another objection for that one. But
so XFS doesn't use this code.
Let me make
yes, precisely. iGet isn't a method. And this get or create inode is extremely bad candidate for a method.
Is extremely what?
Why is it bad? Why is it a bad candidate though?
Extremely bad candidate for a method for superblock. For a good and simple reason. There is a bunch of file systems that are not creating inodes that way, that are not putting them into hash. So making that, it's basically it's...
They're arguing over semantic. They're arguing over fucking semantic. This is gonna be such a shit show. Well, I feel like when two programmers start to argue in semantic, the conversation is over. Because I've never encountered a case where one person has successfully convinced another person that their semantic is better. That's just never happening, because people just reasoning things in different ways. Like semantic is such a personal thing. This is why I hate fucking working on large project that requires large coordination, like, because this is what happened. This is what going to end up happen every single fucking time. You just ended up with like endless arguing and, oh, your take is shit. Oh no, you are actually poo poo. Like, no.
Wrong from the type point of view. There used to be time when we had read inode as a method. Back then there was iGet, which took superblock and inode number.
Yes.
done all that and constructed inode down in there.
So let me tell you what I did. I looked at ext4, looked at how ext4 was building things, and I replicated that here, right? If we actually want to have more generic functions, that's great. We should do that, and we should encode the things on the type system. I'm all for that. About the naming, I get logged, frankly, it's not a great name, right? You look at the name, I get logged. I don't know what that means, right?
Pardon?
But
They are arguing almost semantic. We're so done. If you're starting to argue function name, you're fucked. You're fucked. I think to this day, there's a Windows setting for the trash bin is like the largest maximum size for recycle bin. That shit doesn't mean what you think it means. But the name stuck for years. Like, one thing that is harder, I'm not trying to make a joke, but it's just really hard to argue on semantic, and I just find that to be like extremely counterproductive. Like you can say, okay, like I think this is also like kind of the pride of many programmers, and I feel like if you don't push your ideas that aggressively, a lot of times it's easier for people to accept it. So one example, if I were on the stage, I would just say, we can change the name, but that's not what we're trying to talk about for this example, right? Because they're just trying to arguing Rust has a superior type system, which is true. Anyone who's saying C somehow has a better type system is just delusional. But like that does not help though. Like that's not going to be helpful to anything.
no, exactly. So what I'm trying to say is, yes, I don't mind changing the name. If you guys want this to be called I get locked or whatever it is, I'm fine.
Yeah, he's you don't have to attack your opponent to get your point across. That's what I'm trying to say. Like saying I get locked, it is a pretty, I would agree with the Rust guy, that's not a very clear name. But like you don't have to say like that is a bad name to get your point across.
To do it, but I think we could take the opportunity now to actually put more descriptive names on these things.
It is not a method.
Go on, Christian.
Names be damned, it's not a method.
Okay, it's not what?
It's a library function essentially.
Yeah,
It is not a method of superblock.
it's not a method of superblock.
Yes, precisely because it returns the object in potentially badly inconsistent state. And the reason for that, because I had been, I'm the guy responsible for that bit of
If you don't want this to be a method, we're happy to make it not a method. This is not something I want to fight over.
What would be the type of that method?
Then we'll change self.
C-type system
we'll
is not...
We'll change self to receive a superblock of file system T. That's what it.
Not the problem.
Oh yeah, there's a self. Okay, they're doing OOP. Oh yeah, see, people are getting defensive over OOP.
The real issue is that having that keyed on inode number and having initially, one thing you haven't noticed was that initialization might actually use more than inode number.
Yes, I'm not claiming that it needs only the.
Even in case of I get locked users.
I actually somehow agree with that guy. Like I always hated OOP, and I always hate the syntax sugar of OOP. Maybe I just like reason things in a different way, but I'm just not a big fan of OOP.
You might have additional information you would need to pass to that.
No,
And wait a second, please.
Yep, sorry.
The problem with old iGet back when read inode had been a method, and then it was nice and consistent. You call iGet, you give it a number, it gives you a reference to inode, already initialized. Initialization was done by read inode method, which got allocated inode and used that with number already set. It used that to finish that. Unfortunately, for a bunch of file systems, that led to extremely unpleasant convolutions, because what you really want is opaque object instead of inode number.
Yeah.
Pass to that sucker, and
This is such a shit show. I feel like if the Rust person is more willing to like, fuck, I'm gonna jump into the debate over semantic. I don't like OOP, and I don't like ref self. That is just not how my brain works. And understandably, a lot of C people also don't think that is the way to do it. And if that's the case, like if people or at least Linux people, right? If Linux people actually want to do it that way, they would jump to C++ a long time ago. And so like, I don't know how to feel about this one, but it's interesting. It's interesting to think about that. Like, would the presentation be better if they only focus on what actually matters? Like, keep the name the same, keep the calling signature the same, just like, except forcing the reference counting and like different types and result. Like, that to me seems like a slightly better approach. But at the same time, you know, if I can only say that from the retrospective, if I was preparing this, I would not think about that at all. Just straight out won't. Like, I would not expect such a strong pushback from people. Who knows?
essentially what you want from that read inode is to be partially applied function.
Sure.
Had it been Haskell, sure, no problem. It would be a function that takes inode and returns void.
Yeah.
You pass it to that iGet, having given it inode number as the first argument, if it was a function that takes inode number and inode.
I think there's a little bit of a confusion here. I'm not saying that inode number is the only thing you need to initialize it. I'm saying this is the key you're using to look it up on get or create, right? The inode new that is returned to you is partially initialized. You initialize it, the caller will initialize it. It doesn't come out fully initialized.
I think what's the point also is that we're starting simple and simple file systems. And yes, we will need the full iGet5 terminology very soon.
Yes, we'll get the 5 version, yes.
Yes, and we get redundant methods that makes no sense. That makes no sense on one file system.
If you want the more general version now, I think it's fine for us to drop this and use a general version. This is actually just an example of how you'd encode the requirements of the other ones.
If we make it super complicated, then people are going to complain about checking in code that isn't used yet. If it's only used by the file systems that only need the inode number version, people are always going to complain about something. But we got to start somewhere.
So, two points.
Yep.
Remember that crack about relative usefulness of flowcharts and
I think so.
data type descriptions. Think
Oh my
about
God.
data types first. And
The
what you are doing
nightmare.
is going the other way.
Go to tables, yeah.
So, I think to Dave's point,
I think the self is not good in the way that it really reminds people of C++ and the horror of it.
and also to Al, if I understood you correctly, but my hearing is very bad. we have to decide between generality, I guess, and having a first simple approximation of for an API where a file system can be written in or rewritten. I guess I'm not quite sure if we want to rewrite an existing one or add a new one. And the bigger long-term problem is if you have a function like this get or create inode that encodes a lot more than I get locked, for example, encodes. There is always the danger that you start having a disconnect, and this is, I agree with Dave, that at some point, if we change stuff in the C API, and especially in the beginning, it'll be very likely that a lot more C changes will probably happen before Rust changes happen, and you suddenly have a function that encodes very specific assumptions, and then you somehow need to, basically you need.
I think this point has been brought up again and again. Like, I think Primeagen just completely missed this one. But, like, maintaining two sets of APIs is painful, especially for open source software. And I'm not even sure if it's sustainable or not, especially for a project as large as the Linux kernel.
Need a way to keep these two APIs in sync so that it still makes sense for people that work in the C code, because we don't want to lose like these developers.
This kind of comes down to, do we do refactorings or not? Are we going to do refactorings and clean up and come up with better names? We have to do cleanups and refactoring, otherwise.
Okay, I think this is where the misunderstanding is coming from. I can see why some people would heard it and think this means C people needs to refactor. Or some people might think the Rust people is going to refactor, or sometimes both, right? But yeah, I can definitely see like why some people, if you're in like an defensive mode, you would hear this as in opposition to your position, and you're gonna start attacking the person, which is kind of bad.
We'll have automated tests for that.
Yeah, I mean, all inodes don't have the same life cycle as well. So, I mean, as I said, XFS doesn't call this iGet locked function. It doesn't use any of the inode cache stuff in the VFS. It's got its own inode cache. It does its own inode allocation, does its own inode initialization, does its own inode freeing. Yes. It's all underneath. So it's got a completely different inode life cycle. But we still need to do things like allocate inodes and initialize them and so on. And XFS is, you know, there are other file systems that do various different things with the inode life cycle as well. So a function like that says this is how we create it and this is the life cycle it's going to model it's going to use, doesn't match the way we actually use inodes. And
well, if you're not using the VFS methods, then you're not using the VFS methods.
Yeah. If that's the argument, no file system uses the VFS inodes. The VFS inode is just a structure.
Yeah.
You know, it's an object that is, you know, it's part of the XFS inode. You know, it's a part of the Bcache FS inode. It's part of the ext4 inode.
And that C struct is going to be there for a long time, so I'm not seeing the issue.
So Dave, to your point, let me just respond to that. This is for file systems that actually use iGetLocked, right? For those who use iGetLocked, they would use this, and we can call this iGetLocked. I'm happy to do that. For the ones who don't, who use create or whatever other methods exist, we would create equivalent of those on the Rust API. That would be the idea. Right? So we're not trying.
You just say, I'm going to maintain this shit, right? You just say that. You just say that Rust people is going to maintain the Rust API. When C API changes, they're gonna like follow up with the changes, right? I think one reason why the Rust in Linux has left such a bad taste in the Linux developers is there's so many instances where the Rust developer demanding changes to the C API, and which results in a very unpleasant experience for both parties, right? Like Lena was doing that. Asahi Lena, I'm actually not sure which one's last name, which one's first name, but like Lena was doing that, and many other people were also doing that. Like, I don't know.
Trying to enforce new ways of specific ways of doing things. We're encoding how things are done in the I get locked example here. Right,
This is
what I'm
early
saying.
days. We're not trying to boil the ocean here.
We're almost out of time here, and I suspect part of the problem here is you're trying to convince everyone to switch over to the religion as promulgated by Rust. And the reality is that ain't going to happen because we have 50 plus file systems in Linux. They will not all be instantaneously converted over to Rust.
Yeah, they're definitely talking over each other. This one is the Rust API, right? If you want to do things in C, you can still do things in C. But like, it's just going to be more burden. And also, like, I just don't see how like that's an effective argument, because like, yes, you have 50 or so file systems in Linux, but like that doesn't change the fact that if you're changing the file system API, it's gonna affect fucking 50 file systems. Like, it's going to affect all of those file systems, right? It's not like, oh, you can just change the API and expect everything else to just work magically. Like, the user-facing API is hard to change. And if you're gonna change it, you also have to change the file systems, even in C, right? Like, I just don't see how that is an argument.
Before that happens, we will continue to refactor C code because we want to make the C code better. If it breaks the Rust bindings, at least for the foreseeable future, the Rust bindings are a second-class citizen.
Yeah, I can definitely see that, right? The C people wants to move fast. And it would be really frustrating if they can't do anything unless they pass the Rust test, which they don't want to touch. Right? That's a very fair point. I don't know.
And those file systems that depend on the Rust bindings will break, and that is the Rust.
But again, if you change the C API, those C file systems that depends on the C API is also gonna break, right? Just you either have to change all the C APIs, or you're gonna like tell the Rust people, hey, you gotta change that shit.
Bindings problem, not the.
I think this is just at the end of the day, most programmers are introverted people and they don't want to talk to another person when they can just do the things themselves, right? When everything is in C, if I'm familiar with C, I can just do it. Like, I can have the assumption that everything is going to work. Like, if I make a change in my C file system API, I can just apply the changes to all the 50 file systems theoretically. I don't think you're ever going to do that, but theoretically you can do that, right? But if it's a different language, it's a different tool chain, it becomes really hard.
File system community at large problem, and that's going to be true for a long, long time.
Okay.
And I think we just simply need to accept that,
Yeah.
right? Because the answer, you are not allowed to refactor to the C code because it would break.
He didn't say that though. I don't think the Rust person is. I don't think the Rust guys said anything about, oh, you see, people cannot refactor anything. At least not in this speech. Maybe there's some additional context that I'm missing. I don't know.
5 critical file systems that distros depend upon is like not
But
a
that wasn't the
starter.
answer.
Okay? So like, we'll see. I suspect the best thing to do is you to continue maintaining your Rust bindings. Over time, there will be continued C code refactoring, right? Maybe we will start using, K-free RCU. If that breaks Rust, we will find out whether or not this concept of encoding huge amounts of semantics into the type system is a good thing or a bad thing. And instead of trying to convince us what is actually correct, let's see what happens in a year or two. And it will either work or it won't. And we will see, more likely, where does the pain get allocated? Because with most of these sort of engineering things,
I can definitely see why, like, this is just like avoidance of pain, right? Because I don't want to be responsible for things that I didn't do. Like, I can definitely see people are being so defensive over this, because like, the Rust code are essentially out of their control, right? And having the huge blob of things that are out of your control is a very daunting thought, in my opinion. Yeah, I really don't know how to feel about this one. I just don't know. I actually just don't know.
it's almost always a pain allocation question.
So Ted, let me try to respond to that. I'm not saying that C is going to be stuck in whatever it has. That's not what I'm saying. Yeah. What I'm trying to say is I want for you guys to tell me what the semantics are of these things that will reflect in Rust. That's all I'm saying.
Yeah, that's good, right?
No.
But wait, but the fragility, from my point of view, is the same of any user, right? Users of these APIs, they have to know about the semantics and they have to use them, right? And the rule is, if you make a change, a semantic change, you have to go and fix everybody else who you have broken, right? While Rust is a second class citizen, I'm fine for you guys to say we don't care about this. You guys should look at it.
Here's the thing. You're not going to force all of us to learn Rust. If I make a change,
Why is he getting so defensive? Bro, chill. It's actually getting extremely defensive. Like, I don't, at least just based off of what the speech, like, I think the speech kind of stopped here. Just based off this part, I don't think they are trying to, like, force everyone to use Rust. I don't know. But maybe it might come across as something like that. I don't know.
I will fix all of the C code because that's my responsibility. Because I don't know Rust, I'm not going to fix the Rust bindings. Sorry.
Ted, let me try to say it more clearly. I'm not trying to force you or anybody else to do anything else, right? I'm just asking politely to see if you guys could give us semantic information. That's all I'm asking.
Guys, there is a bit of a problem. I wasn't sure how to describe, but I think now I do. I don't want to insult any language by comparisons with Java, but
oh my god, that's so good. That's so good.
there is a rather sick tendency to confuse functions and methods. Yes, I know about that lovely style that everything is an object and there is an object called.
Yeah, I mean, this is really just the terror of OOP. I think this is like, I think Linux people just really hate OOP, and I also hate OOP. Like, it just left a very bad taste in my mouth.
Called, well, entire program and any unattached function is declared as method of that, but let's not go there. We've seen what kind of shit Java is. Let's try to step away from that. Let's not lose the information, well, what actual methods are and what library helpers are.
The distinction between methods and functions is a much bigger deal in languages that lean heavily on inheritance. Leaning heavily on inheritance is a crap idea, as we've seen in C++, because it makes the thing that you include implicit rather than explicit. Rust does not lean heavily on inheritance. Yeah. Methods in Rust are more a simple syntax change than anything.
Syntax sugar, yeah.
Again,
yeah, there's no concept of inheritance in Rust. We can convert everything, all of these, we can convert them into regular functions, and it'll just take extra arguments.
Okay. I would like to understand one thing. So here you encode some kind of behavior for the inode type, yeah, basically. And I would like to understand. So this because I know close to nothing about Rust. So this actually encodes the behavior only for the callers of the get or create inode, or this actually encodes some properties of the inode type itself?
So the either up there, that encodes INew. So yes, we're bringing things into the type system.
So the inode new has some stuff that is in addition to the regular inodes, right? The ability to initialize it and turn it into a regular inode. But that's still distilling information that is sort of like floating in the C case.
Yeah, because I see here like two different things here. One is like the behavior of the inode type itself, and that's kind of like it's ref counted. You know, when the ref count goes to 0, something should happen, and so on. So this is really the property of the inode type. And then there are other kind of properties like the more advanced thing you have here encoded, and that are not really the properties of the inode type, but they are really properties of this function call, yes. Essentially. Yeah? Yes. Like must check the result is one of the properties yes. of the yes. function call, actually. So.
And that on success, you'll be either a fully initialized or a partially initialized inode. It's also a property of the function, right?
Actually, I would probably describe it a bit differently. Think of encoding inode state as in life cycle stages, and has INew on it is definitely a distinct stage as a different type. Okay. Encode the information about state of inode in terms of FSM. Of its life cycle into the types of pointers. And in that sense, yeah, I would probably pick some fights about exact details, but that's essentially what iGetLocked does. It gives you one, and yes, you need to keep in mind that iCache lookups on the same key running into that partially allocated, in that partially initialized inode will end up blocking, and that information about life cycle gets encoded into type system, and that's actually reasonable. Having some way of when you are trying to audit the code, the first thing you have to do is pretty much figure out which states the objects pointed by this argument of this function might possibly be. Having that verifiable, as much as possible verifiable on compiler level, compilers as parse whatever would definitely be a good thing.
Okay, he's actually getting a whole lot more supportive now.
The question is.
Okay, so the question is
how closely does that match the actual FSM for inodes, and that.
Yeah, I think this is just kept down to like maintaining two different sets of APIs, and like that's where most people are not happy about, which is reasonable. Like like it's just reasonable.
Is where we start with simple ones and then rework it when we run into something more complicated. That
I realized into the talk this maybe wasn't the first thing to throw up there, because this is the complicated case.
Oh no, it is not.
We have much more complicated cases, but this was not a trivial case.
Let's not even talk about SCAT.
Yeah, well, I think it was a great session, great roast. We need to give the storage guys an opportunity to roast the Rust delegation as well.
Yes, we're past the time. Thanks, guys.
Wow, it's such a fucking shit show. I think, I don't know. FOSS world is always such a fascinating space in my opinion, because what a lot of people are talking about, like diversity DI shit, they don't really care about diversity at all. They only care about like different fucking skin colors. And just based off like this one, you can already kind of see like people are from like different cultural backgrounds. They're like, a lot of them are not even like native English speakers, and it's actually kind of challenging to for communication to happen within those kind of environments, because a lot of times people, the reason why people are talking over each other sometimes it's not just the idea but also the language barrier, right? Like, not, I would say like just based off of the accent, I maybe I'm just kind of fucking racist or whatever, but just based off of the accent, it does seem to me like half of the people there are not native English speakers. English is not their first language, and it makes the whole conversation just like a lot harder to follow if both people are not operating within their native language. Does that make sense? Maybe not, maybe yes, I don't know. Just some random thought. Yeah, that's pretty much my reaction to this. Pretty fascinating stuff. I don't know why there are so many open source drama recently. I'm not sure if it's because I started following those drama, or is it because the open source community has like gained so much more momentum after the fuck ups from the corporates, whether it's from Adobe or Microsoft, right? I think like a lot of people are using Linux right now. I think in many ways it makes sense, right? I don't know. It's complicated. Let me know your thoughts down in the comment section. I'm not sure if anyone's gonna let me know their thoughts. Think it's rather unlikely. Cause just based off my old videos, it does seem to me like no one, like literally no one's watching this. But yeah, hope you like it, and I will see you in the next one.